Hi everyone, so we are on our last lesson for the week. Tomorrow is going to be a practice day and Friday is going to be the evidence of learning day. So today we're learning how to solve quadratics by completing the square. On Monday we learned how to solve quadratics by factoring. Yesterday we learned how to complete the square, and so today we are bringing it all together to solve by completing the square. Starting in the Learning from Home folder, scrolling down to the week of May 4th. Today we are on the Wednesday lesson, lesson 3. Today's plan, or you could have went right to the notes through that folder. And it will take us to our lesson 3, notes for solving quadratics in Vertex form. So our learning target is I can solve quadratic functions, which means to find the zeros by completing the square, meaning from Vertex form. So in the first lesson, we learned that we can solve quadratics by factoring. All we had to do was replace the y with a 0, factor, make a t-chart, and solve. To solve by completing the square, which is in Vertex form, we also replace the y with a 0, make sure it is in Vertex form, and then we solve for x. So it's the same idea here. It's still a quadratic. The zeros are still where the parabola intersects the x-axis. So example number 1, it should say, solve the following quadratic by completing the square. So whenever it's a solve, we replace the y with 0. But first, if we're solving by completing the square, we first need to know if it's in Vertex form. And if it isn't, we first need to complete the square. That's what we did yesterday. But if you look at the notes here, yes, it is in Vertex form. So we do not need to complete the square for this problem. Next steps are to replace the y with 0. So here's my original equation. I'm looking for the zeros or the roots or the x-intercepts or the solutions, that's a way to say it, of the equation. So I'm going to replace that y with a 0. And then step 3 is to start solving. Okay, you can see the same equation down here. It says get x by itself, solve like you would solve a linear equation. So I will say again, I like the 0 on the right-hand side of my equal sign, or on the right-hand side of my equation. I don't know why, it's just the way I am. You don't have to do it that way, but I always like to. So if I want to get, x by itself, so this is like how we solve x plus 5 equals 10, okay? We have to get the x by itself by doing the inverse or opposite operations. Okay, so looking at this first equation here, so I'm going to do this all in the equation editor. So we have x plus 3 squared minus 1 equals 0. Now, if you're ever stuck on like where to begin, you are working backwards based on what's happening to x. So like right off the bat, the first thing that's happening to x is that it's being added by 3. Then it's being squared. Then it's being subtracted by 1. So to solve it, we have to work backwards. So the last thing I said was that it was being subtracted by 1. So that's the first thing we have to do to solve it. Okay, so I'm going to add 1 to both sides. Remember, when we solve, we do the opposite operation. So that means we've still got x plus 3 squared. Remember, exponent is that shift 6, 2. Equals 1. Okay, the next part might be the new part. Remember, again, going back to what I originally said, what's happening to x first is it's being added by 3, then it's being squared, then it's being subtracted by 1. So to solve it, we worked backwards. We took care of that 1 first by doing the opposite operation. The next thing we need to attack is the squared. Okay, so you have to think about how we undo squaring something. The answer to that is we take the square root of it. So this right here, we're going to have to take the square root of. What we do to one side, we also have to do to the other. Okay, just the one. Okay, so when we take the square root of the x plus 3 squared, the square root and the square, they cancel each other out. So we're just left with x plus 3. Now, when we take the square root of 1, we get 1. That's what our calculator tells us. But remember, taking the square root means we're figuring out what times what gives me that number. And it has to be the same number that's being multiplied. Okay? Another way we can get a positive is by multiplying a -1 times a -1. So if we take the square root of 1, there's actually two answers. It can be a +1 or it could be a -1 because 1 squared gives you 1 and -1 squared also gives you +1. So the way that we write that is we write it as a plus and a minus. There's the symbol right here. 1, meaning it's a +1 and it's a -1. So from here, what we need to do is we need to split our equation into two possibilities. So x plus 3 could equal +1. I just press tab to create a new table, a new row in the table. Or it could have x plus 3 equals -1. We could have two different solutions here. So let's solve them. So for this first one, we subtract 3 from both sides. And we get x equals -2. For this one, we subtract 3 from both sides. And we get x equals -4. So we have two solutions here, okay? Just a side note, again, creating another row here to keep it organized. We can leave our answer like this, saying we got x equals -2 and x equals -4. Or sometimes they list it in interval notation. So it's basically just, this is a list. Whenever we have squiggly brackets, we're just listing numbers. It's not in between numbers or anything like that. So -4 and 2 are my solutions. So if I graph this quadratic, it would intersect the x-axis at -4 and 2. All right, let's take a look. We got some other problems here as well. So I'm going to do these top two with you, and then you're going to do the bottom two on your own. Okay, so first steps, you can list them as steps if you want. I'm just going to write them in specific lines without the numbers. So if you need help with your first step, scroll back up and it breaks it down for you. Is this quadratic in vertex form? If it isn't, we must complete the square. Is this in vertex form? Yes, it is. Our next step is to set the, because we're solving, so we need to set the equation equal to 0 because we are finding the zeros of the equation. Now, we solve it. How do we get x by itself? We add 4 to both sides, and then we're left with x minus 3 squared equals +4. And how do we get rid of these numbers? We take this, or how do we get rid of the square? We square root it. I'm just going to put it over, see if that's going to work. Nope. Make sure you're inside the equation editor, that blue box around it when you're doing this. That's where my mistake is. Oh, there we go. I'm just going to put the square root across the whole thing. So that gives us x minus, we'll do an equation here. So we're left with x minus 3 equals, and the square root of 4, remember, there's two answers. It's a positive or -2. So we have to break that into two separate equations. X minus 4 equals 2. Let's just solve that one right away. We add 4 to both sides. We get x equals 6. And then we also have x minus 4 equals a -2. Add 4 to both sides, and we get a +2. You can list your answer in interval notation if you'd like as 2 and 6. That's where it would intersect the x-axis. All right, taking a look at number 2, we have x squared plus 12x plus 32. Hopefully you notice this is not in vertex form. So if you need to refer back to your notes from lesson 2, do that. We have to complete the square. So what we're going to do is we first need to identify our a, b, and c values. A is 1. B is 12. And c is 32. Our second step is to take our b term and divide it by 2. We get 6. Next, we square whatever we got. 6 squared, oops, gives us 36. That 36 then needs to be added. I'm going to get rid of the y for right now. I just want the trinomial. We'll get back to the y at the end of the problem. Okay, so we need to, between b and c, so right between these two terms, we are going to add 36 and subtract 36. Okay, then we're putting parentheses around the first three terms to create our perfect squared trinomial. I'll bring the y back in now. Okay, we double bubble. And then we can simplify negative 36 plus 32. We get minus 4. Okay, right here, same signs. And then over near the 12, it's a plus. So it's going to be x plus and x plus. Remember, they're always the same for completing the square. It could be a minus minus. Factors of 36 that add to 12 are 6 and 6. Eventually, you'll be able to jump right to this next step that I'm going to do. And that is to simplify it so it looks like vertex form. Okay, now we're not just completing the square here, we're solving. So now we need to take this equation and set it equal to 0. So we need to replace the y with a 0. I just like my 0 at the end. Okay, so then we want to get x by itself. So add 4 to both sides. We get x plus 6 squared equals a positive 4, not 5, 4. And then how do we get rid of that squared? We take the square root. That means we get x plus 6 equals two different answers when you take the square root of a number. It equals plus or minus 2. So when we subtract 6, we get x equals, that would be a positive 2 minus 6, which would give us a negative 4. Or it would give us a negative 2 minus 6, which will give us negative 8. So in interval notation, that would be negative 8, negative 4. That's where our parabola would intersect the x-axis. Okay, I want you to pause the video and I want you to do 3 and 4 on your own. Once you unpause, you'll see all my work and be able to check your answer. All right, you can check your work. Also, if you see any mistakes that I make, please let me know so that not everyone is watching the incorrect video. Let me know as soon as possible and I will correct it. Because as you may know, I'm human, I make mistakes. And that's all I've got for you. Make sure you self-assess for today's lesson. Tomorrow is a practice lesson, so no video to go along with it, but refer back to your notes if you need them. And Friday is your evidence of learning piece. Make sure you get that into me by Friday at 2:15. Thanks, guys.